Solve the following equations by completing the square, giving exact answers. So no need to use the calculator. So completing the square here, we would get x plus 5 squared. Then take away 25, because that's 5 squared. And then don't forget the 20 is equal to 0. Tidying up, that is x plus 5 all squared. Take away 5 is equal to 0. And therefore x plus 5 all squared is equal to 5. So x plus 5 would be plus or minus the square root of 5, and therefore x would be negative 5 plus or minus root 5. And now for part B. So we know we need half of this coefficient like we did above. And in this case, it's best to leave it as a fraction. So x take away 5 over 2 squared. Then we need to take away the square of that, which is going to be 25 over 4. Take away 2 is equal to 0. So x minus 5 over 2 squared. Now 2, of course, is 8 over 4. So it's going to be negative 25 over 4. Take away 8 over 4, which is negative 33 over 4. And so x minus 5 over 2 all squared would be equal to 33 over 4. And that means that x minus 5 over 2 would be equal to plus or minus the square root of 33 over the square root of 4, which of course is 2. So x is going to be 5 over 2 plus or minus root 33 over 2. And we could tidy that to 5 plus or minus root 33 over 2, although I'll accept that as the answer. So match each curve below with the equation. Let's just zoom this up a bit. So we've got x minus 1 squared minus 5. So from that, it looks like the vertex there would be at 1, negative 5. I've got two equations that are there, but this one has a positive 1 in front here, and this one has a negative. So it looks like the negative one, the one that's upside down, that's going to be C, and the other one is labelled B. Now, x plus 3 squared plus 2, x plus 3 squared plus 2, we're looking for a vertex at negative 3, 2. Again, we've got two of them there, but one of them has a 0.5 in front, the other one has a 2. The 2 will be the one that's most stretched. So that one is going to be D, and the other one is going to be A.